All right, we're back. And our next type of problem would be what's called a transformation problem. This is where we're going to manipulate items according to some set of rules. And so a really good example of that type of problem would be, math. Math is a bunch of rules that have to be correctly applied every time in order to, arrive at the correct answer. So math is a great example of transforming numbers into something else based on rules. Here's a great fun one psychologists love to use, the 6-glass problem. So I'll tell you the rules and you try and figure out what the solution is. So you are supposed to figure out a way to make these full glasses and empty glasses that are presented to you in this order, where you have 3 full followed by 3 empty, all seen like that, as depicted in the picture. You're supposed to figure out a way to end up with alternating full, empty, full, empty, full, empty, while only touching one glass. So how could you achieve the goal of alternating fulls and empties by only touching one glass? So you want to end up with it looking like this. How could you do that? Well, the solution is to take the second full glass, pour it into the second from the end empty glass, and return that full glass, now, which is now empty, to its original position. And so if you imagine that, this second from the left glass has like a residue of milk in it, but it's basically empty. And the one that's second from the right end, is now full because you poured into it, right? Oftentimes we get fixated during these kinds of transformation problems and we think, well, I'm going to have to move 2 glasses. How am I going to do it while only touching one? But you actually don't need to move the glasses, do you? You just need to move their contents. So kind of a riddle example of a transformation problem. Another type of problem is the kind that requires you to rearrange the elements. So all the elements are provided and you have to figure out how to rearrange them. So a good example of that would be an anagram. Anagrams are when you have scrambled words. Now if you look at this list and start unscrambling them, you'll start to see a pattern. So you're like bull, camel, skunk. Okay, now it's getting easier. Mouse. That Baser really made me hesitate for a while when I first saw it. I was like, Baser, because it's pronounceable, so it makes it hard to re-scramble it, doesn't it? But it's zebra. And so the bottom one can be ape, right? So we've got bull, camel, skunk, mouse, zebra, ape. Now this is fun. Here's another list of anagrams. So the first one, corn, onion, tomato, pepper, beet. Uh-oh, look, we have the exact same cue for the final one. But in this context, you're probably going to unscramble it as P. So see those top-down processes imposing themselves here where, once you start to see that it's a list of animals, then it's very easy for that last cue to be seen as ape. When you have a series of cues that are vegetables, it's very easy to see P. And yes, I'm aware that tomatoes and peppers are fruits, so whatever. How about another type of rearrangement of the elements, which would be cryptograms? My grandfather used to love to do cryptograms, and I got to tell you what, I can't do them. Okay, so in this situation, this one actually gives you a hint. I don't think the ones that my grandfather did had these, the number of times each letter actually appears in the cryptogram. And he had to do it with a pen on paper because this was the olden days, right? Before they had games like this on the internet. But what you're supposed to do is figure out what letter goes in each of these boxes. And, I see that there's a single letter apostrophe single letter. So the first thing I'm thinking is that it would be like I'm. So I typed that in there. Let's see how many times does M appear in this. M is not supposed to appear in this riddle at all. It can't be I'm. Let's try I'd. D is not supposed to be in here. Okay, so now I is not supposed to be in here. Okay, what now I'm not faking my complete just flummox by this problem. I'm not faking this at all. I'm honestly like what letters, how do you form a single letter apostrophe single letter with anything else except for I's and D's or M's? But I'm going to go ahead, and I see up here that A is represented 3 times. Is it possible that this little Q here, whoops, I meant to put it here, this little Q here, which is supposed to be a scramble, like it's supposed to be a cipher. So this A is supposed to be like a red herring. Is it possible that it really is representing A? I'm not faking it. I honestly don't know how to solve. This is something I honestly cannot do. I'm going to click hint me and see if oh, see, now that's where the A's go. Okay. Well, and hold on. There's 4 A's in here. Then what does this mean? Okay, I'm completely confused. I don't know how this game works at all. I used to watch my grandfather do it, and I'd be like, how are you doing this rearrangement of the elements problem so easily? Like he could sit there and solve them one problem after the next. I'm like, that looks like a nightmare, Grandpa. How are you doing it? And he's like, oh, it's really easy. You just do. And then he'd tell me the rules for it, and I'd be like, I have no idea. Because it's not like clear rules. They're the like rules of thumb that he used. Oh, I can't do them at all. So if you were struggling with it at all, please, I'm with you. If it looked super easy to you, you and my grandpa would have gone along really well, because I could not do that. Another example of a rearrangement of the elements problem that actually, when I first ever saw this problem, I was completely flummoxed by also, is the horse trading problem. So I thought I would actually share the horse trading problem with you. Here's the idea. A man bought a horse for $50 and sold it for $60. Then he bought the horse back for $70 and sold it again for $80. What is the financial outcome of these transactions? So I am not going to taint you with what my solution was, and hopefully you'll pause me and try and actually work it out and solve the problem. But I can tell you that after my daughter had accounting in college, she laughed and laughed when I told her about how I solved the problem. And she's like, why would you even do that? I'm like, I don't know. It seemed like the way to do it. So I won't taint you and tell you what the wrong answer is. But I will let this video, which is next in our playlist, explain the process to you and see if it makes sense after you hear this person explain how to do the horse trading problem. I'll see you on the other side.